Today I'm talking about field arising from a continuous volume charge distribution. Consider if a tremendous number of charges are separated by minute very small distances. At that time, we cannot distinguish the point charge, and it can be continuous volume charge. These charges are considered to have a charge density rho s. For example, in 3 dimensions, we have point charge, but this point charge distance is just too small, and we cannot distinguish the point charge, and this charge can be continuous charge. So in this continuous charge, we need to define volume charge density. The volume charge density is delta Q and delta V. Delta Q is infinitesimal charge quantity and delta V is infinitesimal volume when delta V approaches 0. The total charge is volume charge density multiply the volume. This is total charge in 3 dimensions. So how to find electric field associated with the volume charge distribution? We have already known the electric field intensity by the point charge. Electric field intensity by point charge is Q1. This is point charge. This is source. Multiply 1. The test charge quantity is 1 coulomb over 4 pi epsilon 0 magnitude r vector minus r prime vector cubic multiply r vector minus r prime vector. As you know, r vector is the field position vector, r prime vector is source position vector. This is Q1 is source, and 1 coulomb. Qt is test charge. The position vector of the source is r prime vector. The point vector of field is r vector. This vector is r vector minus r prime vector. So how about electric field intensity by volume charge density? The electric field intensity by infinitesimal charge is delta Q, the infinitesimal charge 4 pi epsilon 0 r vector minus r prime vector cubic multiply r vector minus r prime vector. As you know, the definition of volume charge density is limit delta V approach 0, delta Q over delta V. So delta Q is rho V delta V. We input rho V delta V into the delta Q. This is rho V delta V prime because this is the source over 4 pi epsilon 0 r vector minus r prime vector cubic multiply r vector minus r prime vector. The total electric field is integral infinitesimal electric field intensity, and this is total electric field by volume charge density rho V. So we take an example. The first example is expressed by x, y, z. So we use rectangular coordinate. This range is x is between 0.1 and 0.2, and also x is greater than minus 0.2 and less than minus 0.1. The range of y is between 0.1 and 0.2, also greater than minus 0.1, 0.2 and less than minus 0.1. The range of z is between 0.1 and 0.2, and also it's greater than minus 0.2 and less than minus 0.1. And volume charge density is 1 over x cubic, y cubic, z cubic. So total charge Q is integral rho V dv prime. dv in rectangular coordinate is dx, dy, dz. So this integral is a triple integral. Rho V is 1 over x cubic, y cubic, z cubic, dx, dy, dz. The range of dx is this 2, and range of y2 is these two range, and range of dt and these two range. So since x, y, z are independent and lower limit and upper limit are constant, we can separate this integration like this. Integral 1 over x3, y3, z3 dx multiply integral 1 over x cubic, y cubic, z cubic dy multiply integral 1 over x cubic, y cubic, z cubic dz. Since x, y, z are independent, we separate this integration. And this integration is A, this integration is B, this integration is C. We find integration A is integral 1 over x cubic, y cubic, z cubic dx. In point of view of x, y and z are constants, so this is 1 over y cubic, z cubic integral 1 over x cubic dx. So we have two range for x, so this is 1 over y cubic, z cubic, and integral from 0.1 to 0.2 1 over x3 dx plus integral 1 over x cubic dx minus 0.2 to minus 0.1. So this integration is y cubic, z cubic. First integration is minus 1 over x squared and from 0.1, 0.2 plus minus 1 over x squared minus 0.2 minus 0.1. So minus is common, so this is minus 1 over y cubic, z cubic, and this is 1 over 0.2 square minus 1 over 0.1 square plus 1 over minus 0.1 square plus minus minus 0.2 square. This is 0. So since integral AA is 0, the total charge is 0. So 0 is the answer of question 1. The question 2 is expressed by rho pi z. So we use cylindrical coordinate. Total charge Q is integral rho v dv d prime. So dv prime in cylindrical coordinate is rho d pi dz. This is triple integral, and rho v is rho square z square sine 0.6 pi, and dv prime is rho dv d rho d pi dz. Cylindrical coordinate rho pi z are independent. The lower limit and upper limit are all constants, so we separate the integral like rectangular coordinate. So this is for dz and z square, and range is from 2 to 4, multiply integral for d phi and sine 0.6 pi d phi, and the range of pi is from 0 to pi, multiply rho square multiply rho is rho cubic d rho. The range is from 0 to 0.1. So integrate this is 1 over 3 g cubic from 2 to 4, multiply this is 1 over 0.6 minus cosine 0.6 pi. Pi is from 0 to pi, multiply 1 over 4, the rho to the power of 4 from 0 to 0.1. So we can calculate it. It becomes 1.1081 millicoulomb. This is the answer of question 2. Answer 3 is expressed by R. So this we have to use spherical coordinate. The total charge Q is integral rho v dv prime. dv prime in cylindrical spherical coordinate is r squared sine theta dr d theta d phi. The rho v is, this is triple integral, and exponential minus 2r over r squared. dv prime is r squared sine theta dr d theta d phi. The range is all range. The range of r is from 0 to infinite because all range, and the range of pi is from 0 to pi, and range of theta is 0 to 2 pi. So we can separate this integration because r, theta, pi are constants and independent, and the lower limit and upper limit are constants. For d phi, so d pi is just we let d pi left and d pi from 0 to 2 pi. Multiply for d theta, we can have sine theta, so sine theta d theta. The theta is from 0 to pi, and r is multiply exponential minus 2r from 0 to infinite. This is 2 pi multiply minus cosine theta from 0 to pi multiply minus 1 over 2 exponential minus 2r from 0 to infinite. So this is 2 pi multiply minus cosine pi minus cosine 0 multiply minus 1 over 2 minus infinite minus infinite 0. So cosine pi is minus 1, sine 0 is 1. 2 pi multiply 2 multiply minus 1 over 2, and 0 minus 1 is minus 1. So this is 2 pi coulomb. This is the answer of question 3. So today we talked about volume charge density. Using volume charge density, we can find the total volume and electric field intensity. Thanks for listening to this lecture, and see you next time. Bye bye.